All right, so what we're going to do is with those kind of different functions we looked at in part one, what we're going to do is we're going to start doing function operations. And some of the operations we've already seen, we added two functions together, we subtracted functions, we haven't really divided functions, we've divided a function by a number, but all of these we've seen in 1400, okay, in your pre-calc or as they call it now, college algebra classes. So we have our inputs x, we have functions f and g, and so what's going to happen is we're going to do function addition, we're going to do function subtraction, function multiplication, and function division. So these are 5 operations we're going to do. In a little bit, we're going to do another one. And when we're doing these, we're just going to take our f of x plus g of x, and we're saying f plus g, and then we're saying of x. And what that does is we just take our function f plus our function g, and as long as their outputs are identical, we can add those two functions together. Same things with subtraction. F minus g of x, well, we just take f of x minus g of x, and as long as our outputs are identical, that's a legal thing we can do. And we just take that minus that, and we get our values. And multiplication, now here we take f times g of x. Well, we're just going to take f of x times g of x. Now here the outputs have to be compatible. So, when you take and cancel units and stuff like that, they have to be compatible units. Otherwise, it's going to end up being gibberish as far as your output units. And so we have to make sure our output units are compatible. Now here, if we do division, f divided by g of x, well, that's just f of x divided by g of x. Now remember, g of x cannot equal 0, or we're dividing by 0. And so again, output units have to be compatible once again. Then our fifth actual function operation is called function composition. Now, two functions f and g can be combined using the function composition if the output from one function f can be used as an input to the other function g. Now, in function composition, the unit of measure of the output of function f must be identical to the unit of measure for the input function g, okay? And so, we're just going to say c of x, which is our composition function, is going to be g of f of x, and that's going to be g of f of x, okay? And so what we're doing is we're plugging f of x in, their output, into the input for g, and then we're going to get out our composition function c of x from that. So we're plugging in the output of f of x for the input for g of x, and it's written g of f of x, okay? Now, because we're doing things that are, what we've already looked at in Math 1400, we also have something called an inverse function. So if we have a one-to-one function, which we'll talk about here in a little bit, g with input variable x, the function f is an inverse of g if f uses the output value from g as its input value, kind of what we're saying up here. And for each output value g of x, f returns g of x to x. So we can plug in g of x into f and we get x out, or we can plug f of x into g and we get x out. So those are inverses if we can do this and plug one output into the other input and get x out, or we can plug this output of f of x into g of x and we can get x out. Now, if it works one way, it works both ways. So you only have to do one of the ways, and I suggest using the easiest way. That's how I show it in 1400, is whichever one looks easier, you do that one. Now, what is a one-to-one function? Well, every output value corresponds to only one input. Okay, so hence one-to-one. Okay, and the way we can test this graphically is called the horizontal line test. So if you remember, for a vertical line test, we had, is it a function? So, something like this, is that a function? Well, vertical line test says no, because we hit the thing here and we hit it here. But if we have, say, something like that, you do a vertical line test, yeah, that's a function, okay? But now we're saying, now is that a one-to-one function? Now we do the horizontal line test. Well, guess what? We hit two places, so it's not one-to-one. But we could have something like maybe, let's say we have this. Well, if we go vertically, this is just going to close and closer to the vertical asymptotes, but it's a function. And if we go horizontally now, it's also one-to-one. So we have to first test if it's function, then we test to see if it's one-to-one, and then we know we can do inverses of it, okay? And so the composition property of inverse functions is kind of what we just did over here. You know, f of g of x equals x and g of f of x equals x. So what we're saying is same thing, except now we're kind of blowing it out into showing the f of g of x is equal to x and g of f of x is equal to x. But what that means is we're just doing the f of g of x and g of f of x. And that part there kind of says how we're doing it here. So that's a composition property of inverse functions. Again, if it works for one, say it works in the first one here, then we don't have to test the other one. Or if it works in this one, then we don't have to test the other one because they would be inverses. All right, so let's do some composition because you've probably been a while since you've done any. So let's do f of x equals x squared plus 2x, and g of x is 6 minus x squared. And we want to find f plus g, f minus g, f times g, and f of g. And we're assuming here that all of these are legitimate. So we don't have to worry about, does it fit this, does it fit that? We're saying, okay, this fits all of the conditions that we said it had to fit. And all we're going to do is just take the f plus g, f minus g, f divided by g, and f times g. So for the first one, f of x plus g of x, we're going to do this one. So we have x squared plus 2x. Now we just add that, plus 6, then minus x squared. Okay. Well, x squared minus x squared, guess what? Those cancel. So if we want, we can say, okay, well, we just cancel those out and they're gone. We don't have to worry about that. And then what's left over? Well, we have 2x plus 6. And that is what f of x plus g of x is. Well, what about b? F minus g. Well, that's just going to be f of x minus g of x. Well, we just take f of x, so that's x squared plus 2x. And then we subtract off 6 minus x squared. Okay, and I put that here and this in parentheses because you could just say, well, I'm going to subtract everything off, so I could take minus 6 plus x squared. Or if you put it in between, you have to distribute that negative. And so we get x squared plus 2x minus 6 plus x squared, because we're distributing that negative. Now we have like terms. We have an x squared plus an x squared, so it's a 2x squared. Then we have plus 2x, and then minus 6. And that then is what our f minus g is. All right, what about f times g? So that's going to be f, well, f times g, but we're going to write it out the whole way. F of x times g of x. Okay, well, we're just going to take x squared plus 2x, and then we're going to multiply that by 6 minus x squared. And now we just FOIL. So we're going to take, that times that, that times that, that times that, and that times that. So x squared times 6 is 6x squared. And then we'll have that times that. So it's x squared times the negative x squared. So it's a negative x to the fourth. And then we'll have this times that. So it's going to be plus 12x. And this times this is going to be a minus 2x cubed. All right. So now if we write in decreasing orders of power, we'll have a negative x to the fourth. And then we have minus 2x cubed. And then we have plus 6x squared. And then we have plus 12x. Okay. So then that is going to be what our f times g is, or f of x times g of x. Now what about f divided by g? Well, again, we're just going to plug in what we have. So we're going to have f of x divided by g of x. Now remember, g of x can't be 0, but that just means here that this can't be equal to the square root of 6, basically. Okay. All right, so f of x, we have x squared plus 2x. G of x, we have the 6 minus x squared. Well, now we think about that. Well, we could factor out an x, and that's going to be an x plus 2. Now this one, it's going to give us radicals and things like that if we try to factor that. So that's really not going to help. So, we could leave this and say, well, it's a minus x squared plus 6. and there's nothing really we can do. So really we could say, well, that's our final answer, or if we wanted to, we could say that's our answer. It all depends on how you want to do it, but this really, that's about as simple as we can get, because even if we factored out the x, that doesn't help us. If we factored this, that really is not going to help us. We could factor out a -1, that's not going to help us. So that is about as far as we can go with this one here. Okay, so that's doing our, f minus, f plus, f times, and f divided by g of x, those operations on functions. All right, so we'll stop there and we'll continue in a little bit.